Before we get started, we'd like to thank our sponsors for making this event possible. Special thanks to our platinum sponsor, OLAS. OLAS enables everyone to own a share of AI, specifically autonomous agent economies. We're also excited to highlight our silver sponsors: NIA, empowering decentralized applications and blockchain ecosystems; Venice AI, a private and uncensored alternative to popular AI apps; Mira, unified AI infrastructure, secured by crypto; and Theric, the first on-chain multi-agent system. To learn more about all of our sponsors, check the description below and dive in. Enjoy the show.
Hello everyone, welcome to DAI Month at Delphi. Today we are talking all things infrastructure, from the frontiers of decentralized compute to storage to pushing the limits of what can be done at the edge. This is Pondering Durian from Delphi, and I am joined by a stacked lineup of panelists today. So we have Greg, founder of Akash, we have Mohamed, founder of ExoLabs, and we have Michael, co-founder and CEO of Zero G Labs. Gentlemen, welcome to the Delphi podcast.
Nice to be here.
Thanks for having us.
Yeah, likewise.
Yeah, so maybe we just get started with kind of quick intros, and then for people that might not be familiar, just a 10, 20-second download on your project, what you guys are working on, and then we'll dive in. So Greg, maybe we start with you.
My name is Greg. I'm the CEO for Overrated Labs and the co-founder for Akash. Akash is the world's first supercloud. A supercloud, like the name suggests, is a supercluster that sits on cloud-capable compute and offers a cloud-like interface while providing a market-driven price point and a decentralized mechanism to access hard-to-reach resources, particularly high-density GPUs.
Awesome. Michael.
Well, hey everyone, I'm Michael, co-founder and CEO of Zero G, also Zero Gravity in the long form. What we're building is the first decentralized AI operating system, and we started at the data layer. So we made sure that we created a decentralized storage network that's fully available, has fast data ingestion and retrieval rates at costs up to 80% off centralized systems, specifically made for AI workloads. On top of that, we built a data availability layer, which can get throughput of up to 50 gigabytes per second per consensus layer, so that we can eventually do fully on-chain trading for large-scale LLMs. And then soon we'll be releasing something called the serving framework, where anybody can register as a serving node and offer things like inference and fine-tuning kind of services to the rest of the ecosystem. We really want to be the connective tissue between a lot of Web3 AI projects.
All right, Mo.
I'm Mohamed. I work at ExoLabs. What we work on is essentially allowing you to run any AI models yourself on your own hardware. So there are many great efforts to democratize AI, like Meta creating these best models in the world, like for Llama 405B. But to use these models, you still need to have multiple, like in the case of Llama 405, you need multiple H100s. What we do with Exo, which is fully open source, you can aggregate any compute you have, like a few MacBooks, and run any model fully privately on your own. And that's it. It's just your own little private cluster. There's no network involved, anything controlling you, which allows you to run stuff uncensored. You can run stuff privately. You can run stuff for free as well.
Okay, awesome. And as the guests can tell, I think we have an interesting group where, we have folks that kind of started from the decentralized cloud side and have been expanding outwards. Other folks, trying to essentially transform what decentralized storage and retrieval looks like. And then Mo, kind of you coming at it from the opposite angle, pushing things out of the cloud entirely and kind of, what can be done on local devices at the edge. So I think we have some unique perspectives to kind of go at this infrastructure conversation with. But I guess the first topic I really wanted to talk with is kind of more directed at Greg and Michael. And it is the conversation around demand, particularly in competition with the hyperscalers, right? And so obviously these are massive markets, but you are going up against pretty dominant incumbents. And so I am curious, how you guys think about your go-to-market. And Greg, maybe we start with you. It does seem like in Q2 and Q3, you guys have seen, some nice momentum. So kind of curious to learn a little bit about where that demand is coming from, and kind of how you guys have started to hone your go-to-market motion. But yeah, so just curious to learn about kind of the demand side, and some of the recent customer wins that you guys have had in Q2 and Q3.
Right. So demand side, we had our So we measure our success in our progress in leases created, and leases a deployment or an application. Last quarter, we saw a 50% gain compared to the previous quarter in terms of leases. So it's clear growth there. In terms of revenue, compared to last year and daily fees, we 10x'd by a full order of magnitude essentially. So there's clear demand in terms of users paying money to deploy. But when stack up to hyperscalers, we're nowhere close in comparison, right? And the reason for that is right now the economies of scale are playing a big part, especially with training, but it's also showing cracks, right? So we saw like what happened last year, where yes, you had these hyperscalers which have massive amounts of compute, but they were hyper selective in terms of who gets the compute. So that led to a lot of frustration across the industry. And we saw a lot of researchers, AI companies trying to look for alternatives. I think we caught a bit of that windfall, and we were able to leverage that to gain momentum and establish ourselves as a serious player. Our big win out of the whole scarcity of GPUs was NVIDIA. So NVIDIA being one of the few protocols integrated into Akash. NVIDIA's Brev in particular is it uses Akash's compute because in Akash's model of going to places where compute is available but not available to be used by general public, particularly companies that are doing machine learning or doing crypto mining that have a bunch of GPUs, like high density GPUs, A100s and H100s, that they're not using for various reasons. So Akash can go to places like that and make that compute available in a decentralized manner. So that's in an open source manner too. So that's very attractive to companies like NVIDIA, because NVIDIA obviously want to serve users, but they're unable to because of supply chain constraints, and they most certainly don't want to lose users, especially researchers and academics who have quite a lot of influence on the future of AI, to alternatives, be it AMD, right? So they want to keep as many users as possible in the NVIDIA ecosystem, and one of the ways to see that come to fruition is by repurposing underutilized supply or underutilized GPUs. So I think that aligns quite well with NVIDIA. We're also seeing quite a lot of a whole cohort of users that have been priced out or unable to get access, like researchers in universities. So we saw University of Texas using Akash quite a lot. We saw Rochester Institute of Technology using Akash quite a lot. There are rumblings about other universities that are leveraging Akash because, in order to get a GPU, at least it was extremely hard even till about a few months ago to get these H100s and A100s. There's a story in Semaphore about how a kid from Cornell was unable to get GPUs from Amazon, but it was able to get on Akash and create a company that got acquired by NVIDIA eventually. So we have some success stories that are in the wild that use Akash, and I'm really glad to see these users come to fruition. Our next big leap when compared to hyperscalers, I think our biggest there are two sets of innovations, and I'm super impressed with what ExoLabs is doing with Mohamed, leading the effort there with decentralized inference, right? So being able to, or distributed inference rather, being able to leverage distributed compute clusters to do inference on massive models, 405B, is a big win because bringing that onto a decentralized network where the primary advantage is access to resources that are locked away under private networks, and using XO we can leverage those hard to get resources and do so in a much more scalable manner, right? And what we're seeing with decentralized training, with efforts like Dialoco or Distro by News Research, Dialoco from Google DeepMind, and Open Dialoco from Prime Intellect, that is proving that we can actually do training across geographically distributed clusters. So we have training and we have inference, and it's only time that these technologies will come to fruition, and XO is doing fairly well. in terms of adoption, in terms of recognition, by the general public, right? So it's only a matter of time that the decentralized networks that can leverage distributed compute will be challenging hyperscalers because of these technologies that are getting to main stage.
Got it. Yeah, we'll definitely get to decentralized training, but I want to get Michael in here as well. So kind of also on the storage side, right? We've kind of seen, maybe less inflection in terms of some of the existing solutions than we might have hoped for. So I am curious, kind of what you intend to do differently at Zero G. And obviously performance is one thing, but kind of some of the other keys that you guys are pulling on in order to kind of change the paradigm.
Yeah, specifically on the storage side, the issue has been in distributed and decentralized systems is that most of the storage that's been offered has been in the form of cold storage, which I think is only a small percentage of like all storage that's needed. And so if you're just doing kind of log cold storage, it's really hard to retrieve, it's really hard to store, then you're not really meeting the use cases that you need for AI. And so what we've done is we've added multiple levels of abstraction so that all Web2 data types are actually now found in Web3 as well. So you've got the log storage on the bottom, then you've got a key value store, and then you even have transactional storage that you can store onto our network. And with that, essentially come fast data retrieval and ingestion rates that you need actually for it to be completely usable. So we've run a test, for example, doing fine tuning with a 7 billion parameter model. And after a few minutes, basically our storage system caught up and there was no overhead compared to centralized solutions. And so finally, we have the kind of technology available that can actually do that. Other issues with some other systems include the tokenomics themselves. So in some systems, you have to actually pay upfront for kind of permanent storage. And given how quickly these models expire, why would you want to, for example, store a 7 billion parameter model that's going to be out of date next month forever? So we make it a very kind of flexible use case. So we're targeting about $5 per terabyte per month. For our storage solution, so it's really easy to adopt and then really easy to use, just like you would a centralized solution. So that's on the storage side. You asked something about kind of go-to-market as well. For us, we're primarily focused on Web3 AI as our go-to-market, so really early adopter market. We've seen a lot of phenomenal traction. We have about 300 projects or so building on top of us. We've recently had spikes of about 5 million transactions per day or so, which has been growing about 100% kind of week over week. So we feel really, really positive about some of the traction that's coming our way. And it's going to take a while to catch up with the hyperscalers on whether it's, storage or compute side, but I'm very hopeful. For example, I read a study, I think that was maybe 2 or 3 years old, where the hash rate of Bitcoin was basically compared to all of Google's data centers. And Google's data centers at that time were only 1% of the entire hash rate of Bitcoin. So we've shown before that we can do it as a decentralized space, and I'm very hopeful and excited that we can catch up in 2 to 3 years' time or so.
All right, looking forward to it. And Mo, I guess switching gears a little bit, kind of just thinking about what can be done on device versus in the cloud, and specifically around trade-offs in latency, in privacy, and in cost. So yeah, I am curious to kind of get your thoughts on what makes most sense to be done locally and also in the cloud, and specific use cases that you guys are excited about at Exo.
Yeah, so in general, I try to think about it not so much what's good local, what's good for the cloud, but more like what is the problem you're trying to solve and which type of solution makes sense. And you have all these options available. There's on device, there's maybe locally with multiple devices, there's maybe a hybrid local and cloud, and there's maybe fully cloud. So it really depends on the problem you're trying to solve. One of the problems that I'm very interested in that makes sense in the local bucket is if you get privacy, there's all these cool technologies like FHE and so on, but really the simplest and best way to be private is just do stuff on premise. So, and privacy for retail is a little bit of a meme. Like, I care about privacy, but most people don't really use social media, Web2 all the time. But businesses do. Like for businesses, legal privacy is often like a real thing, and hedge funds, bio companies, law firms, and so on, like legally have to be private. So from that perspective, what I think about it is, well, what is the easiest way to have stuff on premise in the context of AI? Buying GPUs and setting them up and maintaining them is very hard. Like you literally need to be an engineer to like buy GPUs and set them up privately yourself, and also it's expensive. So with Exo, what we think about there is just like if you already have loads of hardware in a company or as an individual and so on, could you reuse that to do stuff on premise because you care about privacy? If you think about performance, like it's very hard to match the performance of like NVIDIA GPUs in a data center with anything on the edge. So like if you just care about more tokens per second, it's very unlikely that you'll be able to do that locally versus the cloud. But if you had the constraint of a business of I legally have to be private, then the trade-offs are very different there. It's not like general like cloud versus edge. It's more like for this specific context, you have these extra requirements, and then something may make sense to the other. And in general, like what the kind of things that could make sense locally are things we care about privacy, things we care about low latency. For example, if you play a game, that little bit of latency between your device and the cloud can make the game really annoying versus like everything on device. I think Cursor AI actually is really interesting, a place where you have hybrids. You have like, Claude and ChatGPT, like the main code generation, but you have a few like very small models sitting on device for things like text completion, which just like makes Cursor so much nicer to use than other things that are fully in the cloud. But also, if you have Cursor only locally in your device, you would not be able to like use Claude, for example. And Claude is like, an incredible model. Like Claude Sonnet 3 is like, personally, I really like using it. And these things are very hard to do locally. So it depends like what you're trying to do. And often cloud makes sense, often the hybrid makes sense, or the edge. And the edge stuff is typically if you care about cost, latency, privacy, and so on. That kind of category, there might be a solution that is edge or a solution that's hybrid.
I like that framing. Makes a lot of sense.
One thing maybe I'd add our perspective on kind of device versus kind of fully decentralized is that whenever there's like societal level kind of issues involved, so if AI agents or models are going to run kind of full production systems or logistic systems or administrative systems, they really have to be governed kind of through blockchain economics, so slashing and incentive conditions versus on device. But everything else we think is very appropriate to be on device as well over time as they grow in capacity and so on.
Yeah, on that point as well, there's often when you think about these problems, there are two types of AI things you use. There's single player and multiplayer things. Like a chatbot is just like, a single player thing. It's just like me using it and that's it. So that can happen on device. But there are things that just could never happen on device. Like literally, for example, if I want to run like a social media algorithm or a credit score, like these are naturally like, multiplayer things. So even if you care about privacy or trust or verifiability, and you could do it on device, it wouldn't work. Like I could run Uniswap on my single local device. Like it's not complicated formula, but like it doesn't work that way because it's a multiplayer setting. So that naturally can never be fully offline. I couldn't turn the internet off and run Uniswap myself because it's a multiplayer game. And the same for a lot of like things like insurance or social media platforms and so on.
Yeah, super aligned.
All right, switching gears a little bit, but I am curious about each project's superpower. So kind of what is the core essence of your project? What is the one thing that you do better than anybody else? So if you had to point to one thing that succinctly defines, why you guys are creating value uniquely relative to competitors, what would that be?
Well, so I can start off. I mean, the biggest value I think Akash gives is truly open source and truly open community, right? So today Akash has about 500 contributors, all contributing in a open setting. And Overclock Labs, the company behind Akash, employs about 25 people. So majority of the contributions come from outside the company. And that's extremely critical for network effects. And that's extremely critical for survivability on the long run. Yes, you can create companies as a closed source system, but in order to create communities and protocols, you need to be open source. And that is the foundation of decentralization. Without that foundation, I believe you cannot have decentralization. So that's why I take up quite a lot on closed source systems that consider themselves as decentralized systems. I think there's no place there. On top of that, I think other competitors, Akash has got a phenomenal orchestration advantage. In terms of resources, Akash, you get, like any cloud, you can get access to storage, ephemeral storage, or even persistent storage, as a matter of fact, to IP addresses, to a global orchestrator. Like, you can have one single file that can configure workloads across the world and connect them, interoperate with them, with hundreds of data centers, right, in a single setting, and along with other resources, be it compute, be it GPUs, be it bandwidth and whatnot. So it's a whole holistic cloud, instead of just a simple GPU network.
Got it. Mo, how about you?
I'm not sure what we do really good. I think a lot of bad stuff. Maybe one thing that we do okay is...
Greg was just giving you a lot of love, so you're doing something good. So feel free to brag a little bit.
Yeah,
they're open source.
Yeah, I guess we're open source. I guess one thing that we do good is it's what some people refer to as like user-owned AI. Like with Exo, you literally can just be offline, off the grid. You don't need to do anyone, and you can like have the models yourselves. I made this demo once where I had something like running in my like phone and local cluster, and I just turned the internet off. I told her, "I am lost. Help me," which is to symbolize like if you don't have like internet access, or if OpenAI shuts you down, there's nothing you can do. But like in these like very local models, you could just have your own little like self-sovereign model. So that's, I guess, a good thing we do. Yeah, I'll keep it there.
That's a good thing.
Being extremely humble here. Let me add, I think what they do incredibly well, at least the way I see it. They bring sovereignty to AI like no one else can bring sovereignty, right? There's nothing that beats a private AI, a private model that doesn't leave my network. So cases like diagnosis, like I had a recent episode, for a health diagnosis that I didn't want to talk to ChatGPT because I know ChatGPT is going to share my data. I had no idea who's looking at my data, right? For something like that, I had to spin up a model on Akash, which takes about 5 hours to boot, and costs a lot of money, right, on H100s and whatnot. If I had a model in my home running on my local compute, unused compute clusters, with my wife's MacBook, my MacBook, my child's MacBook, I can easily talk to the model and have the privacy guarantees. And I think privacy is extremely underrated in the world of, massive AI adoption. And what I think ExoLabs is bringing is the true sovereign private models that no one else can offer.
I hope your diagnosis all went well, and hope you're healthy and happy.
Oh, I am healthy and happy. It was just the diagnosis. I had a lot of questions I couldn't ask the doctor during the diagnosis, so I came back and asked the Llama 3.1. It was incredibly resourceful. But yeah, in a scenario like that, I wouldn't be comfortable asking ChatGPT. I'd rather want a local model. I know that I have privacy guarantees.
Nice, makes a lot of sense. Michael, how about you?
Yeah, definitely hope everything's okay with you, Greg, and all best wishes if any recovery is needed. On our end, I'd say we're very good at pulling out kind of the most hardcore kind of engineering and research talent out of top programs like MIT, Stanford, Tsinghua, and as a result, from kind of like Turing Award winner kind of classes and so on. And as a result, we have 5 Olympic gold medalists in informatics on the team, which then leads us to build kind of fully on-chain AI solutions that are actually truly decentralized, and then also have the performance requirements necessary for on-chain AI to actually really work. And so that's kind of why we had this breakthrough around, for example, the data availability layer. We've been able to showcase that each one of our nodes can do about 30 megabits per second in terms of throughput, which is already 3x what most entire networks do. And so it's horizontally scalable, so you can get to 50 gigabytes per second, which is similar to what InfiniBand does in data centers from a throughput perspective. So I would say that's what we contribute, is kind of brutal high performance throughput.
Well, that is 5 more math Olympiad gold medals than we have at Delphi. That's for sure. But all right. So I guess I was going to stop. This is kind of halfway through. I was going to do a quick round of overrated versus underrated. Are you guys game? Just very quick answers, just right off the cuff. Is that okay?
We can always edit stuff out.
Yeah. If I don't think these are going to be too spicy, but all right, we're going to jump in. So Google's current valuation, it's $2 trillion.
Underrated.
Underrated?
I would say in the long term, underrated if they can get Gemini to consistently be fully integrated and as performant as other solutions.
I would say underrated. They have so much going on for them. The AI is really good. The TPUs are very good. I don't know why they don't get too much love. And they have so much cash to buy nuclear reactors. So,
well, my PA certainly hopes you guys are right. All right, number 2, the scaling laws as kind of our road to AGI and ASI. Obviously, Mohamed, you're a fan of the bitter lesson. You guys think this can continue? Overrated or underrated?
I think I would say overrated. I believe in the scaling and that scaling works, but you need to scale the right things. And I think just like dumb scaling is not quite what works, but like scaling generally is the right direction. So like slightly overrated.
I'd say overrated as well, just because I think alternative approaches may get us to AGI same way. So, for example, what if you put millions of smaller language models together in some type of LLM middleware? Is that going to have a better result? So I think more experimentation needs to be done.
I would say that's scaling, but just in a very different way than like dumb scaling, as in more parameters. So that's why I think it's overrated.
That's true. Yeah, different types of scaling.
yeah, I mean, I agree. I think it's overrated. I'm a history buff, and I've been studying quite a lot of how humans evolved in terms of intelligence. We evolved not because our brains got bigger. We evolved because we started talking to each other better, mixing, and through diversity, it came through our evolution. We stopped evolving physically about 10,000 years ago, but we got smarter over time. And so, it's not necessarily throwing a bigger model that may result in better intelligence, or better smartness. But really, I think I believe it's going to be, or not I believe, but I have there's a strong probability it's going to be a lot of smaller models that may come together. That may lead to an AGI, right? So, but it's a high chance.
Yeah, the network of networks, Internet of Intelligence model is certainly one we are rooting for. But all right, next one. So I know you guys are multifaceted. It's not all technicals and AI. So we're going to shift to economics. The de-dollarization narrative. You guys think King Dollar is here to stay, or there's real legs behind de-dollarization and other economies, shifting off the US dollar? Michael, I'm going to put you on the spot.
Overrated or underrated?
Yeah.
What
overrated,
if I say
underrated.
it's like, what if it's like right in line? I think there is going to be kind of national challenges, but it's going to take quite a long time before that happens, and it's also going to take quite a bit of time for digital currencies to catch up. So I'd say it's right in line with what most people think. So
all right, properly rated. All right, Greg,
Yes.
What do you think?
Overrated.
Overrated.
For a long time. Yeah, and the reason is, the petrodollar, and now I think it's going to be semiconductor dollar. It's going to be, energy dollar, right? Especially the semiconductor dollar. I don't think people are paying too much attention the power US has over semiconductors. Right now, it looks like TSMC or Taiwan has all the talent, but the shift really started happening in the 90s, and we are not that far away from bringing back the talent to US. Whoever owns semiconductors will own the economy, and the world is so fragile and so connected to the US dollar that any disruption to that stability will bring about a lot of chaos. So we have bigger problems to fry. We have energy problems. We have semiconductor problems. We are accelerating, and I think like the what do you call the decline of the Chinese economy really showcases that there is really no other competitor to US in terms of how fundamentally and organically strong the US economy is. And that has to do with the exuberant privilege that we have as the creators of the dollar. So yeah, I think it's heavily overrated.
Overrated.
Yeah, heavily overrated. It's not going to happen in a
Got
long
it.
time, but that doesn't mean it won't happen, but it's going to take a very, very long time. Definitely not in the timeline that people think is going to happen.
Mo, very quickly. We've got a lot of things to cover, and Greg's got to drop soon. So
I haven't thought about this much before, so I'll pass. But Greg sounded smart, so I'll just agree with that if I have to answer.
all right, we'll take it. And one word answer: AGI by 2030. Overrated, underrated. Greg, let's start with you. Underrated?
Underrated.
Okay. Mohamed?
Underrated.
Underrated. Okay. Michael?
Yeah, same, underrated.
Underrated. All right. I like it. We've got some bulls here. All right.
I got another
we're going to
one.
shift. Sorry?
Type 1 civilization by next 50 years.
I don't know what that means. What's the type 1 civilization?
So Kardashev scale is this. So type 1 civilization is this civilization that can leverage all sources of natural power on a planet that planet naturally generates, and a planet that has, I suppose, planetary defenses to combat external threats. So Kardashev is this, like, I guess, Soviet scientist astrophysicist who came up with these scales, like type 1, type 2, type 3. So type 1 is supposed to be this like really advanced civilization. Type 2 is supposed to be like a civilization that can harness stars using what do you call the thing around the stars?
50 years. We have 50 years to terraform the stars.
Mohamed, no, not really. 50 years to be a type 1 civilization. That means a civilization that can harness all the energy produced on Earth. That's really what type 1 civilization is. And right now we're at 0.7. Type 0.7.
Okay. Well, I mean, if you guys are this bullish on AGI by 2030, I think a inflection to super intelligence might see us at type 1 pretty soon. So I'd be bullish. I'd take the under.
Well, underrated means you're bullish?
Yeah.
Oh, underrated. Okay.
Yeah. Well, yeah, I think like we would get there faster. But all right. I'm switching. I'm going to get us back on track here. So I do want to talk a little bit about decentralized training, which is something that came up earlier. And obviously there was the distro announcement from Gnosis Research. And I always thought decentralized training was kind of going to be the bottleneck for DAI, but some of these results were pretty impressive. So I am curious to get y'all's thoughts on decentralized training versus kind of the current SOTA and how quickly, or if at all, these approaches might catch up and the timelines there. So Michael, I know this is kind of, near and dear to you guys in terms of data transfer. So I'm curious to get your thoughts.
Yeah, we think parity probably in 2 to 3 years. We're doing a bunch of research on it as well. I think there's a few fundamental constraints. Like one is, how do you do batch training? How do you do asynchronous training? How do you deal with network latency? So once you figure those 3 things out, then hopefully you can coordinate a mass amount of GPUs across the network and figure all this out. Then there's also the issue of how do you do verification in such a way that you don't rerun the entire kind of compute, because that wouldn't make sense. It's already super scarce to get GPUs. If you then have some consensus and you need to like verify via consensus, that makes no sense, because then you're just like rerunning it. So how do you get the cost of verification super low in that type of environment as well? And so once we figure those few things out, then I think we can get to the holy grail of, hey, now we can use all these GPUs that are fully available and let's go train bigger models. But that's only part of the equation, like figuring that out. What about the data side? How do we unlock new forms of data? How do we unlock private data? How do we unlock synthetic data? And so all of that is going to be very important in our journey as well for training. So I would say, yes, there's the compute issues, but there's also other issues we have to figure out.
Got it. And then I do, I guess, switching Mohamed to you, I have heard you talk a little bit about kind of hardware scaling versus software scaling. And in crypto circles, there's a decent amount of emphasis in terms of scaling underlying blockchains using software solutions like ZK coprocessors or OP coprocessors. But obviously the hardware is also getting better, both in terms of what is used to train the models and in terms of the chips that basically end up on devices. So curious to get your thoughts on, whether blockchains actually end up scaling better through software or through hardware, or maybe like just privacy in general.
I'm not sure I fully get the question. I guess like in general, scaling software versus hardware, in cases where scale worked in the past, like machine learning breakthroughs, like chess games, like transformers and so on, what worked quite well is like fairly general methods scaled with like really good hardware. So like the best methods for like image recognition were not like network state of image recognition and handcrafted approaches. It was like CNNs that just like discover on their own, like what the features are and all this stuff, and like scale to really large size. Um, I'm not sure in the context of blockchain if like what the trend exactly or but sorry, yeah.
Yeah, so I guess I was thinking about like how do you actually instill blockchains with a decent amount of scaled computation, given they are relatively slow. So obviously 0G is taking one approach, and then you can also just use like I'd say better chips and TEEs and do things using hardware.
Yeah, I mean, so when I think about a blockchain, is like we're using a blockchain because like a central server is bad because we might be trusting it. I'm not sure if there's a case where use a blockchain because it's more efficient per se. It's more like, well, I don't want to be censored, and given you want to be censored, then what is the best thing you can do?
No, yeah. Well, I guess like obviously you would want both. You would want high performance and like distributed and trustless environment. But
yeah. I guess like I just struggle to see in which setting like a blockchain solution is just better performance wise than just like a trusted solution. Because if you can build these things in a setting where you don't trust everyone, then surely the setting where you do trust everyone is just more efficient. It's just like we use the blockchains because we have to. Because like I mean I don't want to trust X, Y, and Z, so that's why. But yeah, I hope that makes sense.
Got it. Yeah, makes sense. And I know Greg's running out of time. So last question. I am curious, like why each of you decided to focus on this specific problem, and what does success look like for Akash, for 0G, and for Exo, 5 years, 10 years out. So just mission, and then kind of your personal KPIs as leaders of these organizations.
So for Akash, I mean, the journey goes back to 2014. So I've been a early contributor to cloud native technology stack, be it Terraform, be it Kubernetes, Docker, and whatnot. And the dream was really to create an open source cloud, right? So we were able to, until about recently, we are able to create open source software, but it was not very clear on how to create open source networks, right? I think that's where decentralization came into play. And our vision is cloud, which is perhaps the most important fabric that holds our modern society together, and a very important public utility, should be as free as the air we breathe and the water we drink. And the access to which should not be gated. And that was the whole premise of starting Akash, and we still are on the vision, right? For us, success we measure in market share, right? So our first milestone would be 1% market share of the cloud business, and the reason we think we can get there is because as compute gets more relevant especially with AI. There's a case to be made that compute will become a necessity in terms of ownership. So people will have compute, own compute. And unlike the current scenario where, we have mobile phones and which are significantly less powerful than these centralized servers, which are sitting on the cloud, this pattern is not going to be permanent. I think we're going to go back to the older pattern where we have more power at the edge, and like like what I described about like having private models, or my house, I'm building a little data center to be able to run my own AI. I think, and we have a lot of devices on the edge that are very powerful. And we have Tesla vehicles. I mean, Elon was famously quoted about 6 months ago talking about how they can leverage GPUs on Teslas. There's a lot of compute on the edge that's not being used. So that makes me extremely optimistic in terms of if we can build decentralized technologies, can leverage this compute and the software stack to complement this distributed compute that we can use for useful things, we can effectively get to the market share realistically. So that's how we measure success.
All right, Mohamed, kind of mission and success for Exo.
Yeah, just the way what I think about is democratizing AI means frontier models available to anyone. So there are two pieces here. There's some ways to create frontier models. Right now, it's like Meta, and the second part is like once they're created, you need to be available to actually use them. Because, for example, right now, Llama 4.5b is like hardly anyone can use it. So that's the two things we think about. And most of our effort right now is on like the second. It's just like we assume someone has created these open models. We're trusting that Zuck will keep financing this for a while. And given that these models are available, we want to just make it lower the barrier to entry as much as possible. And there are multiple ways you can think about it. There's the business metrics, for example, like the value of the company based on like how many customers we have and so on. But I think a lot about like just how close we are to the world, because I think about it. I also personally just think a lot about the existential risks of that. Like my PhD was in robotics, and at the time you always had all these fears about robots like killing people and so on. These are not the most obvious. These are not like the most likely fears. Most likely fears is like right now when I need information, I used to go to Google, look at different websites and read it. In the future, I might just go to ChatGPT and ask it something, and then you just get a biased response. Like these are the things that's like the more real fears, like truths being obfuscated and so on. And we have internal KPIs for those two goals, like creating frontier models and making them available to everyone. And that's what I think about motive success. Because also like the business metrics look good, but in a world where AGI exists, I'm not sure that even matters. They're important to keep track of. And obviously for the discipline of like making sure you're on the right track, we look a lot at these business metrics. But really, I just think about like the vision, like democratizing AI is frontier models available to anyone, which means someone needs to create them, and we have to guarantee they'll be created like without having to rely on like Zuck or something. And the second one is just like once they're created, you need to be able to run them. So, and we have two internal metrics for that I think about, and I think we talk about those a lot more. Obviously, if the business metrics are also important, but almost secondary to these two metrics for creating frontier models and like running them.
Got it. And what are you going to do post ASI when you're made redundant? How are you going to spend your time, Mohamed?
I can't. My brain is. I'm not big brain enough to think through that scenario. My brain.
You haven't got to the type 1 societies that we're going to build yet.
I'm still like my IQ level is like fine-tuning models or like building a small system. I can't think about what I will do in a world in which super intelligence exists. I don't have the IQ points for that, but maybe we'll get there if I augment myself with an AI or something.
It sounds like it's coming soon. All right, Michael, over to you and Zero G.
Well, our mission is to make AI a public good, and so we want to avoid a world where AI essentially wakes up one day and says like, hey, I can do this much better without humans. And so we basically want to make sure that AI consistently serves humanity's needs, is fully aligned, is safe. And for that, we take the very strong stance that there's no future in AI without blockchains. And that's the future that we're building towards. We want to get to technical parity with centralized, or what we also call closed AI systems, hopefully in 2 to 3 years. And after that, then really build on the superpowers that blockchains give us, things like alignment and security and prevention from kind of nefarious actors, and fair rewards distribution, kind of the verification, the trustlessness, so you can actually independently say like, hey, is what I'm being served from this inference request actually truly true? And so we want to see a world like that happen.
Okay, I think that is a really good place to end. So thank you guys. Really appreciate you taking the time, and really look forward to watching y'all's projects evolve, because I think you guys are working on really important things. So thanks for coming on the DAI Delphi video conference. Appreciate it.
Yeah, thanks for having us.
Yeah, I really enjoyed it. Thanks for having us.